Today we are going to talk about combination circuits. We will be discussing what they are and how to solve a problem. We will start this video by going over three basic terms that are important to understanding this topic. Current with the variable I is the rate at which electric charge moves through a given area. Voltage with the variable V causes these charges to move. Resistance with the variable R is opposition to the flow of electric current. The three types of circuits are series, parallel, and combination. Combination circuits are a mixture of series and parallel circuits, so to understand combination, you must first understand series and parallel. We will start with series circuits because they are the basic circuits. They are basic because the current has only one path to follow. The current leaves the battery and the same amount goes to resistor 1 and resistor 2. The voltage of the two resistors always adds up to the total voltage of the battery. The voltage of each resistor depends on how much resistance the resistor has. The total resistance of the circuit can be found by simply adding up the resistance of the resistors. Next, we will talk about parallel circuits. Parallel circuits have the same components as series circuits, but they are found in a different way. This is because parallel has multiple paths that the current can take. The current leaves the battery and has the option of picking a path. Once it picks the path it wants to take, it drops off an amount of current at each resistor on that path. Whatever current does not take the one path takes the other, and they both add up to the total current. No matter what path the current picks, the voltage is the same throughout the circuit. When solving for resistance, use the equation 1 over R total equals 1 over R1 plus 1 over R2, etc. These are two equations that are very important for solving circuit problems. Ohm's law deals with voltage, current, and resistance. Power, voltage, and current are in the power equation. As long as you have at least two of the variables, you can solve for the missing variables. This is an example of a combination circuit. It combines series and parallel circuits. These are the steps for solving combination circuits. First, identify the components in series and calculate their equivalent resistance. Redraw the new circuit. 2. Identify the components in parallel and calculate their equivalent resistance. Redraw the new circuit. 3. Repeat steps 1 and 2 until the circuit is reduced to a single equivalent resistance. 4. Work backwards to find the current and voltage for each resistor. 5. Find total current using battery voltage first. 6. Solve other variables like pieces of a puzzle using your redrawn diagrams. These steps will be more easily understood when you watch the Solving Combination Circuits video.